Good morning, children. Yesterday we had discussed on remainder theorem. Today we will proceed on the same method and we will discuss some more examples. So here the question is find the remainder if x raised to 4 minus 2x square plus x minus 1 is divided by x minus 2. When we will divide the given polynomial by x minus 2, then first of all we will write p of x, means polynomial of x raised to 4 2x square plus x minus 1. Now this is our divisor, x minus 2. So x minus 2 is divisor, and so first of all we take x minus 2 is equal to 0. Now this minus 2 shift the other side, so we will have x is equal to 2, and this value we will substitute in the given polynomial. So we will have p of 2. Here 2 raised to 4 minus 2 square plus 2 and minus 1. So we have substituted the value of x in the given polynomial. Now we will simplify. So 2 raised to 4 power, so it becomes 16 minus 2 square means 4 and 4 multiplied by 2, 8 plus 2 and then minus 1. Now 16 minus 8, 8 plus 2, 10 and 10 minus 1, 9. So remainder of the given polynomial x raised to 4 minus 2x square plus x minus 1 at x minus 2 is 9. As per the division algorithm, p of x is equal to q of x into g of x. G of x means p of x means the given polynomial dividend, q of x which is quotient, g of x means divisor, and r of x means remainder. Here we are not aware with the quotient, but we are aware with the remainder. So the question can be asked that without dividing, find the remainder. Without actual dividing, find the remainder of the given polynomial. So at that time also you have to use the remainder theorem. So if we know the quotient, then if we substitute over here, then multiply it with divisor, and then if you add the remainder 9, definitely you will get the given polynomial. But that method we will discuss later on. Now we will discuss the another example. Without actual division, find the remainder without actual division, find the remainder of polynomial x, x cubed minus 2x squared plus 3x plus 1 when divided by x plus 1. When we divide x plus 1, or when we divide the given polynomial x cubed minus 2x squared plus 3x plus 1 by x plus 1, without actual division, it means we are going to use the remainder theorem. So, very first, x plus 1, this is our divisor, and when the x plus 1 is equal to 0, it means x is equal to minus 1. So here we can say that when x is equal to minus 1, at that time x plus 1 becomes 0. Now we will substitute this value in the given polynomial. So t of x is equal to x cubed minus 2x squared plus 3x plus 1. And we will substitute this value x is equal to minus 1 in the given polynomial. Cube of minus 1, that is minus 1, square of minus 1, that is 1, and then multiply with 2. So 1 to the 2. Three into minus 1, minus 3, and then plus 1. Simply by minus 1, minus 2, minus 3, minus 3 minus 3 minus 6, minus 6 plus 1 minus 5. This is the remainder at p of minus 1. So interpretation of p of minus 1 is that in the given polynomial x cube minus 2x square plus 3x plus 1, when we substitute in the place of x as a minus 1, we get the remainder minus 5. Yesterday, we had discussed a sum like to find the unknown value. So here, let's try to get the unknown value. So here we will get the clear idea that whether we are correct or not. Second thing, the how to find the unknown value. Suppose here I am making a little change. So now my polynomial is p of x is equal to x cube minus ax square plus 3x plus 1. When we divide it by x plus 1, our given remainder minus 5. So dear students, here you will be very much clear that when you have to find any unknown number given in the polynomial, at that time remainder will be given to you. So either you find remainder or you get the unknown value. So anyone else, out of this both, anyone if you have to find, then the other value will be given to you. So here remainder is given minus 5 and the polynomial is p of x is equal to x cube minus ax square plus 3x plus 1. So previously when we had solved the sum by dividing x plus 1, we got minus 5. So when you will use remainder in the question for the solution, so now you are very much clear that at last for the a, what we will get? 2. So let's check it. Here our divisor is x plus 1. So x plus 1 is equal to 0. So x would be minus 1. This x, value of x, we will substitute in the given equation. P of minus 1, minus 1 cube, minus 1 square, minus 1 and plus 1. Cube of minus 1, that is minus 1. Square of minus 1, that is 1. And 1 multiplied by minus a, that is minus a. Minus 3 and plus 1. As in the previous example, we had discussed that minus 5, it was the value at p of minus 1. Minus 5 was the value at p of minus 1. So here, this remainder we will write as a value of p of minus 1, which is a given remainder. Now, minus 1, minus 3 is minus 4 and minus 4 plus 1. So minus 3 and minus a I have minus 1 minus 3 minus 4 minus 4 plus 1 minus 3 I have. So minus 3 minus a is equal to minus 5. Now this value, if I substitute, then I will have minus 5 plus 3. Minus 5 plus 3, that is minus 2, is equal to minus a. Hence, a is equal to 2. A is equal to 2. So, our answer is correct. Second thing, that you have come to know that to get the unknown value, the remainder is given, that we will substitute over here. To get the unknown value, we are using the remainder theorem. Now another example we are taking. Here again we have to find the unknown value, which is k. We have to find the unknown value, which is k. Our divisor is x minus 2 and my remainder is 3. So first of all, x minus 2 is equal to 0. So x is equal to 2. This value we will substitute over here in the given polynomial. Three 2 cube minus 2 2 square minus k plus 5. Here the value at p of 2 is 3, which is remainder, and so we will substitute over here 3. First of all, cube of 2, that is 8, and 8 is a 24. Square of 2, that is 4, and 4 to the 8. Minus k plus 5. 24 minus 8, 16. And 16 plus 5, 21. Now we will substitute this 21 to the other side. So we will have 3 minus 21 is equal to minus k. So we will have minus 18 is equal to minus k. So finally we will get k is equal to 18. Check this sum properly. cube of 2, that is 8. 8 3s are 24. Square of 2, that is 4. 4 2s are 8. Minus k is as it is because it does not have k, plus 5. But suppose here k become constant because it is without variable. But now if I here this dual term is constant. Let me remind you, this dual term is constant. So it was without x. So it is considered without variable. So it is considered as a constant. And finally we get by simplification 24 minus 8 plus 5, it is 21. 21 shifted other side, 3 minus 21, we have minus 18. So the value of k is 18. But if you are asked that what should be the constant over here, then the constant will be 8 minus 18 plus 5. And that will be minus 13. So overall polynomial will be 3x cube minus 2x square minus 13. Now, if I use x with k, then let's check what kind of change we will get at last. So we will have 2 over here. We will have 2 over here. So we will have 2k and remaining part will be as it is. So 24 minus 8 plus 5, that will be 21. And at the end, we will have 18 upon 2. And 18 upon 2, that will be 9. So now, for this polynomial, because now the polynomial is changed. So if the polynomial is changed, remaining parts are same, but the value for k will be also changed. So by remainder theorem, we can use these kind of unknown numbers. Given polynomial p of x is equal to x raised to 4 minus 3x cube plus kx square plus 2x minus 5, and divisor, that means g of x is equal to x minus 1, and r of x means remainder, that is 2. Now x minus 1 is equal to 0. So x is equal to 1 we will have. We will substitute this value in the given polynomial. Then in the place of x, we will write 1. 1 raised to 4, 1 cube, 1 square, 1 and minus 5. 1 raised to 4, 1 cube, 1 square, 1 and minus 5. What is the value at t of 1, which is our remainder? 2. 1 raised to 4, 1. 1 raised to cube, 3. 3 ones are 3. 1 square is 1, 1 into k, that is k, plus 2 and minus 5. 1 minus 3 minus 2 and plus 2 is 0. So finally we will have k minus 5 and minus 5 is shifted other side. So 2 plus 5 is equal to k. So k is equal to 7. So our polynomial will be x raised to 4 minus 3x cube plus 7x square plus 2x minus 5. Dear students, if we make change over here, means remainder is changed. It means the value will be also changed over here. So here you will get an idea that for the particular value of x, you are getting the particular value for the polynomial, particular value for the unknown number. So now we will take another example, but which are little different. P of x is equal to x raised to 4 minus 3x raised to cube plus ax square plus 2x minus 5, and two divisors are given. The one is g of x is equal to x minus 1 and the other one is m of x is equal to x minus 2. Remainder for both divisor, when you divide p of x, the remainder is same for both, 1. So kindly copy down this question and try to solve and get the value for a and check that are you getting the same value when you divide it by x minus 1 and when you divide it by x minus 2, or different values that you have to check. So copy down this question and try to solve it by yourself. Now, till this method, you are given the divisor and you are finding the remainder or else value or else 0. But in all these previous questions, the polynomial is given, means dividend is given, and divisor is also given. But in the next method, divisor will not be given. I mean to say that if the divisor is not given, at that time, how to find the factor or divisor? Factor means, as you are aware with this word, that which can divide the dividend perfectly. It means that remainder is 0. So, for example, if you are asked that just you are asked that divide 2x cube plus x plus x square minus 2x minus 1. 2x cube plus x square minus 2x minus 1 if you are asked to divide, but divisor is absent over here. So how to get an idea? How do we know that by which binomial or which divisor we can divide? At that time, we will add all the coefficients and constant. I am repeating, we will add all the coefficients and constant. So, if I add 2, here the coefficient is 1, minus 2, and the constant is minus 1. And if we get answer 0, then the factor of this polynomial will be x minus 1. It means when you divide this given polynomial by x minus 1, then you will get remainder 0. So let's try. Our polynomial is 2x cube plus x square minus 2x minus 1. In the question, divisor was not given, but I find the divisor by adding the coefficient and constant. So 2 plus 1 minus 2 and minus 1, and at the end I am getting 0. So my conclusion is that x minus 1 is a factor, and you know very well that if it is a factor, then definitely the remainder will be 0. So here x minus 1 is given, x minus 1 we get. So if x minus 1 is a divisor for us, so the value of x will be 1. Now we will substitute this value over here. Then cube of 1 is 1. 1 2s are 2. 1 square, that is 1. 2 ones are 2 and minus 1. 2 plus 1 3. 3 minus 2 1 and 1 minus 1 0. So remainder of the given polynomial at p of 1 is 0. So we can say this is a factor. But here, by adding the coefficient and constant, in this question we are getting 0. And if we are getting 0, then and then only we can say x minus 1 is a factor. But if here the sum is not 0, at that time, which would be the factor of the given polynomial? So that we will learn in the next session. Thank you very much. Have a nice time.